Assalamu alaikum. My name is Umar Haroon and my group members are Waheed, Amir and Abdul Rahman. I'll be presenting our computer network's term paper titled Issues in Cloud Computing Adoption. Introduction. So cloud computing is basically the distribution of computing resources as utilities. So for example, if a user needs a lot of computing power or storage space to store all their data, instead of having to take the cost of buying all the computer hardware, the hard drives and the CPUs necessary to perform all those tasks, instead you can pay a third party vendor to provide you the infrastructure instead, and you can access that infrastructure through the internet. And this kind of computing can work on very small scales and large scales as well. For individuals like you and myself, a good example of such a model is Dropbox. We use that all the time, or Google Drive. We use it to upload our data and keep it safe without having to worry about backups or integrity, and without having to worry about infrastructure costs. Now this can work for large companies as well. They can store all of their many millions of terabytes of data in a cloud, use it for quick analysis and access it at any time they want. The architecture of most modern cloud system deployments is very modular and consists of four major layers: the hardware layer, the infrastructure layer, the platform layer, and the application layer. Now the hardware layer is basically all of the actual hardware infrastructure that the cloud is running on: the servers, the hard drives, the CPUs, etc. The layer that sits directly on top of this layer is the infrastructure layer, or the virtualization layer, which is probably the most important part of this architecture. This is the layer which implements all the virtualization technologies in the cloud computing, which allows the cloud to redistribute all of its resources to its different users and partition them to different users depending on their demands. This is the major factor which distinguishes cloud computing from technologies such as grid computing, which have been around for a very much longer time in the past, and that is the virtualization technologies that are used in the infrastructure layer of the cloud. Now after this layer is the platform layer. This is a layer between the infrastructure layer and an application layer, which provides a little bit of abstraction in between the two layers, so that developers who are making applications have an easier time utilizing the virtualization technologies of the cloud. This examples of software running on this layer is Google's App Engine. So it's basically an API which allows developers to easily develop web apps using cloud infrastructures and easily use the virtualization technologies. And lastly, there's the application layer, which are the actual applications that you're using on the cloud, such as Dropbox, Google Drive, YouTube, even those are all on the applications on the application layer of the cloud infrastructure. Deployment strategies. So there are three major deployment strategies used in modern day cloud computing, and these clouds are known as public clouds, private clouds, and hybrid clouds. A public cloud is a cloud that will always be in use by millions of users around the world. The third party vendor will rent out the resources from the public cloud to as many users as the cloud can handle. And it will some examples of such a cloud will be again Dropbox and YouTube, which will be in use by millions of people around the world at the same time. Now this is a really good way for individual users to get access to computing resources very cheaply. However, in a public cloud, issues of security and data integrity remain. Public clouds will not be as secure in maintaining your data or keeping it safe from hacking attacks as private clouds or hybrid clouds. A private cloud is a cloud that is intended to be used privately by a single organization or group. This is basically a cloud that is privately owned by an organization to house all of their data for them, and no one else except the organization can ever access this data or store any data in the cloud. Having a private cloud gives the organization a lot of control over their data and its security. They can choose to maintain the cloud themselves if they wish, or they can hire a third party vendor as usual. However, it will still be a little bit more costlier to set up a private cloud and maintain it than it would be to just use a public cloud. A hybrid cloud is basically a mixture of both the public and the private clouds. It's basically a single cloud that uses the virtualization technologies discussed previously to partition the cloud into different sections. One section will be a private cloud, which will only be used by certain organizations or people, and the other will be a private cloud which can be rented out to anyone, anywhere. So it combines the best of both worlds. Now, one thing that cloud vendors need to be careful about while maintaining hybrid clouds is the ratio of public to private, or how much resources should they utilize should they allocate to the private cloud, and how many resources they should allocate to the public cloud. There are three major types of business models utilized in cloud computing: software as a service, infrastructure as a service, and platform as a service. Now, infrastructure as a service is very simple. Vendors will just rent out actual utility power, computing power, such as storage space and CPU power to companies, and they can use it as they wish. In platform as a service is basically they provide you a platform on which application developers can easily develop their apps on, such as the Google App Engine. It's basically an API which developers can use to develop apps, and this kind of service is mostly aimed towards developers of applications. Now, the third type, software as a service, is a very simple and common form that most of us use day to day, again, such as Dropbox and YouTube. These are services that we can use and pay for if we want to use them at a premium rate, and we can access them simply through the internet. And now we'll talk about the main issues in cloud computing which hinder the growth of the industry, and some of the major reasons why major corporations in the world are still very reluctant to adopt cloud computing for their computing and data analysis needs. Now, the biggest and the most obvious reason is security. This is one of the major reasons why corporations are often reluctant to give their data to a third-party cloud vendor. If they give all of their data to a third-party cloud vendor and gets hacked or compromised in any way, then it results in huge business losses for businesses. And even if individual users end up losing their data, it can hurt the cloud computing industry a lot. Now, maintaining 100% security in a cloud is very, very difficult for a number of reasons. Some of the major reasons are, first of all, inconsistent security practices in various data centers that the cloud computing vendor might be using. Now, to provide their services, one data center will never be enough for a cloud vendor, and to ensure availability of resources, often a cloud vendor will have multiple data centers in many different parts of the world, and each of these data centers might have a different policy towards security, and it's hard to maintain a certain standard of security at all of them together, especially if all the data centers are located in different countries, different parts of the world with different laws, etc. Another major issue is multi-tenancy, which basically means that each cloud is being used, especially public and hybrid clouds are used by millions of people at the same time. This opens up the cloud to a lot of makes the cloud really vulnerable to attacks from hackers, and it gives them a way to access the infrastructure from the outside. The software as a service interaction business model is especially susceptible to hacking attacks, because oftentimes the interaction between the user and the cloud takes place through a web browser, and hackers can use the exchange of metadata that occurs between the browser and the cloud to gain access to users' accounts. Now, the second major issue with cloud computing is availability of service and reliability. If a major company stores all of their data with a third-party vendor, they want to be able to access that data and utilize the business intelligence tools 100% of the time. Even a little bit of downtime can cause a lot of financial damage, to the business. However, maintaining 100% availability all the time can be very difficult for a cloud vendor. One of the main ways cloud vendors will tackle this problem is by having multiple different data centers all around the world, so that even one of them fails or is somehow hacked or fails, then at least the other data centers can pick up the slack and still the service can resume. However, a single service provider having multiple data centers is still usually not enough, because having one service provider itself still counts as a single point of failure. And if the data provider is suddenly attacked by hackers, or if they just go out of business, then the company that was hosting their data on their servers will be at a major loss. So the only real way that a company that's hosting its data on a cloud can deal with this problem is by using multiple cloud vendors for their to provide their service. Just as ISPs will usually use many other smaller ISPs to make sure that even if one of them goes down, they can resume the service by so that other ISPs can pick up the slack. The companies will have to do the same in order to ensure 100% availability all the time. Now, another major issue with cloud computing is the cost of actually transferring your data from your own computers or systems to the cloud itself. Bandwidth can be very costly, and costs for uploading data have gone up to about $100 to $150 per terabyte uploaded. And as the companies and software become more and more data centric, the amount of data that will need to be uploaded will only go up, and the costs will add up, and at some point this becomes very unfeasible for many companies, including many smaller companies. And the cost of the bandwidth is not the only concern. The time that it will take to upload all of this data is also a concern. For example, uploading just 10 terabytes of data to a data server, which is not that much by today's standards, on a 20 megabit internet link can take up to 45 days, which is a lot of time lost that could have been used much more efficiently. Now, one solution to this problem is not to use your internet at all to upload your data, and instead send the data to the service provider physically by storing them in hard drives and shipping them to the service providers themselves. Now, this solution is far from ideal, and the physical cost of shipping can also be great, and it carries a great security risk, and it will not work for data transfers that are not delay tolerant. But in many other cases, it can be a very cheap and quick way to transfer large amounts of data. For example, in the as earlier mentioned, 10 terabytes over 20 megabit link can take up to 45 days to transfer. Instead, if you ship it via hard drives on a train or on a boat, it can or on an airplane, it can arrive to the data center within a few days at most. However, if your data is not delay tolerant and it needs to be transferred within a few minutes or a few instants of being generated, then this solution will not work for you. Another major issue with cloud computing is scalability. Now, as time goes on, applications become more data centric, they produce more and more data as they go on. Now, storing all of this data can become a huge problem, and scaling cloud computing, like adding more and more storage storage capacity in a cloud, is getting harder and harder. This is still an open problem and doesn't necessarily have a definite solution to it yet, but some people have suggested using virtualization technologies in order to scale the capacity of the cloud down and up dynamically according to the user's demand. As their demand for storage goes up, you allocate more resources of the cloud to storage to that user, and as it goes down, you free up that space and allocate it to other users instead. This is a way to cope with high demand of data, but it is not a permanent solution to the problem. Now, the final major issue that we've discussed about cloud computing in this paper is cloud inoperability or incompatibility. Now, as we discussed before, there are no standard regulations for how cloud should operate or how they should interact with users. So most companies who have clouds have their own proprietary APIs and ways of interacting with user systems, which means that they cannot usually operate or communicate well with one another. So if a company has hired more than one vendor to house all of their data, it is very difficult for them to have the two clouds communicate between each other and transfer data from one cloud to another, which can be an essential need for a for a company that is utilizing more than one cloud vendor. So in conclusion, while there are many major issues such as security, bandwidth, cost, availability, etc., that hinder the growth of the cloud computing industry today, all of these issues are still solvable and will get solved as the industry and the technology starts to mature. In the end, we believe that widespread adoption of cloud computing utilities is only inevitable, and that it will be a major part of the future of the IT industry. Despite all of these issues, it is a very promising technology that holds a lot of potential for the future of computing. And this concludes our presentation. Thank you for watching.